is an honor for me to have a chance to talk to so many young people who are interested in science and engineering to the point where you're willing to spend so much time and energy on these robots. And I've been thinking now, what can I say to you in about 4 minutes, I haven't timed it exactly, that you might remember? What kind of advice can I give you? And here's what I got. I think you should try lots of things. That's a statement like knowledge is good or be nice to people, but let me tell you what I mean by that. In science and engineering, trying lots of things is known as experimentation. So let's talk about what this first experience has been like for you. You tried first because you wanted to learn more about robots and engineering, and now you've learned things that have value to you. You have insights and skills that make you a wiser and more capable person. And one of these insights might have come to you because when you worked your first design problems, I'm willing to bet that your first idea was rarely your best idea. For example, think of some of the approaches that you tried in designing your robotic arms. You had to decide what kind of linkages to have, how many linkages you want, and how you would control them. You've got terrific processes and tools for predicting what would happen when you built your design, but it just wasn't real until you built your arm and watched it work. So I want to tell you about some experiences I had. It's hard to talk about work, so I'll tell you about when I was at MIT getting my doctorate. I was working with a guy named Bob, and we thought we could come up with something called a two-dimensional planar photonic bandgap material. I know you have no idea what that is, and no one else did at the time either. It was almost a math problem. And the idea was we wanted to design a material that had this little band gap in it. We worked for weeks on the computer. We tried all kinds of different geometries and configurations, and finally we got one where the computer said the math was right, it had this gap, and we built our first sample of the material and it actually worked, it had the gap. And at the time, we published it, and it was kind of published under miscellaneous topics because no one knew what a photonic band gap was, and I was just happy to be getting my degree. But then a couple years went by and someone used the material to make a tube for a laser so that you could burn out polyps in cancer patients' esophaguses without having to break their jaw. And then I realized, that was a really good thing, and it was worth a couple weeks to try to find that material. So you can use this experimental approach in all kinds of situations in your life. Maybe someday you'll go to cooking school. You'll experiment with recipes. Maybe you'll start a business and you'll experiment with what kinds of products people want to buy. Maybe you'll start a family and you'll have to experiment with how you get everyone to get along. And this is one of the most important things I've learned in science and engineering. When I'm doing something new, just like you, I never really know how it's going to turn out. And over the years, I've learned that you embrace the situation, you jump in, you take the plunge, and you watch how the events unfold. And that's what we'll start to do now with your competition. Good luck. I wish you all success.